demonstration of a silicon nanowire using a plane wave DSP and MD molecular dynamics is implemented as that. And this is just with an FDM image of silicon nanowires. And they have a lot of uses in material science that are being explored. And the main characteristics of them and what makes them different than amorphous materials is they show strong
density of states for the anion and the cation of the polymers. And this is a little bit surprising because we would have expected some partial filling to go up right about here, at least on one of them, to show some overlap. So I'm taking this to mean that there's not much delocalization in the system, which makes sense because there's no conjugation. So that might have been why it didn't show this. The other highly likely possibility is I messed up the calculation, but we'll pretend that didn't happen. Okay, here's the band structure absorbance spectrum. And as you can see at 0K, the HOMO and the LUMO are close enough in energy that we can call this a direct band structure, similar to amorphous silicon. However, this is a little bit surprising because this does show order in one direction. And if we take something that's completely ordered like crystalline silicon, that has an indirect band gap. So exploring the transition at which something goes from having a direct band gap to an indirect band gap would be also an interesting area of research. And as a final thing, I wanted to see the reliability of Koopman's theorem for density functional theory. And I found out, first of all, it's actually not called Koopman's theory, it's called Janak's theorem, because he was the one to prove that the first vertical excitation energy and the electron affinity are related to the HOMO and LUMO in the CHEM792 formalism. In my system, though, this was not the greatest. My error was 9.96%, which, once you take that into electron volts, that could be pretty huge. And so my main conclusions are that we can model these using this molecular dynamic plane wave DFT approach. We can successfully model the thermalization of the silicon atoms and other things, and maybe apply this to a plasma chamber, which sounds like a good idea project to me. So, are there any questions?
Let's thank the speaker.
Hey, just forgetting this issue.
Okay, if